infrastructure or any kind of execution details. And while containers remove complexity through minimalism, they managing container deployments, it presents a new challenge for IT operations, right? Containers are deployed for typically much shorter periods of time than VMs would be, and there's greater utilization of those underlying resources. Related container technologies, they have to manage far more objects with greater turnover. They're introducing the need for automated policy-driven management. And so teams are turning to things like Kubernetes in its rich set of really complex features to help them orchestrate and manage containers in their test, development, ultimately their production environments. And Kubernetes has really emerged as the de facto standard for container orchestration and management, and it's becoming a critical platform for organizations to understand. So, what is Kubernetes? So, ultimately, how do you manage these containers? I had to throw in kind of a Michael Scott, somehow I manage, because, this is becoming a big problem, or I should say a big blocker for a lot of people who are early on in their container adoption. Maybe they're just running stock, Docker, they're containerizing their applications, but how do you manage configuration or service discovery and resource scaling? How do you configure a cluster so that there's failover whenever you're getting degraded container performance, things like that. Containers are popular because they allow an application to run as an isolated process with its own resources. And so containers are unlike VMs. They allow Linux to manage the compute resources rather than performing the costly operation of actually virtualizing that hardware. And so it's a lightweight, and that means that each application gets its own container that prevents any kind of dependency conflict. So, more simply put, think of a container like a tarball or a zip file. With that in mind, containers are just a way of bundling the code, the configuration, and then the dependencies of that application. And so this bundling eliminates the problem of, if it worked in my environment, why doesn't it work in yours? Ideally, applications produce the same output regardless of the environment. And containerization really makes that idea or that ideal easier to reach. And containerized applications will start to stop, make requests, and they'll log the same way in different environments. But ultimately, applications are increasingly built as kind of discrete functional parts. And each of these can be delivered in a container. So that means for every application, there are more parts to manage. There's shorter lifespans than traditional VM-only deployments, and the complexity of managing applications with more objects and kind of greater churn, it introduces new challenges. So configuration, service discovery, load balancing, resource scaling, discovering and fixing failures. Managing all these things, it's complex, and doing it manually is virtually impossible, right? Clusters commonly run more than 1,000 containers, and updating those clusters is really infeasible without some kind of automation behind it. And so what Kubernetes allows you to do is deliver a production-grade container orchestration by automating container configuration. And essentially, it simplifies the scaling of that, and it manages the resource allocation. And so you can run Kubernetes anywhere, whether you want to run it on site, on your own infrastructure, on a public cloud, maybe a hybrid configuration on both. But essentially, Kubernetes is what's delivering scale. And so, in a nutshell, for these complex applications that are consisting of multiple components, containers vastly simplify updates. You place each component in a container. That makes it simple to make changes without really having to worry about any kind of ripple effect. And that simplicity leads to containers becoming a great way to develop and deploy microservices. Microservices, which are applications with a single function, they naturally benefit from containers because they provide really a clean separation between components and services. And so Kubernetes, it's an open source container orchestration platform, and it helps manage these distributed containerized applications at a massive scale. So you tell Kubernetes where you want your software to run, and then the platform takes care of pretty much everything else. So what Kubernetes provides is a unified API You can deploy web apps or batch jobs and databases, whatever the application is. The applications inside of Kubernetes are packaged in containers and are cleanly decoupled from their environment. So Kubernetes really automates the configuration of your apps, and then it maintains and tracks the resource applications. So what is container orchestration, right? So, Kubernetes is container orchestration. That means Kubernetes figures out where and how to run your containers. And really more explicitly, it provides three functions. So schedulers and scheduling. Schedulers essentially compare the needs of a container with the health of your cluster, and they suggest where new containers might fit. So think of a scheduler as, someone, maybe an executive assistant who's managing, your CEO's enormous calendar, right? A controller consults the scheduler, and then it assigns the work and monitors the container. So really a better example is, you have your thermostat at home. And so, you set it to 70 degrees and you expect it to maintain that temperature. And so the thermostat is constantly checking the temperature and it's resolving it against the settings, so 70 degrees. And it's doing that on a regular interval. And so when you set a temperature, the thermostat seeks to maintain that temperature on your behalf. In the same way, Kubernetes is seeking to maintain cluster health on your behalf. And so you're freed from really kind of minding the temperature, so to speak. Your developers can just focus on building their apps and providing value for your business. So the second thing that it provides is service discovery and load balancing. So in any system, service discovery, it can be a challenge. And Kubernetes, it's no exception. And so the more services that make up your application, the more difficult your application is to track and to manage. And so what Kubernetes does is it automatically manages the service discovery piece. So we might ask Kubernetes to run a service like a database or a RESTful API maybe. So Kubernetes takes note about these services, and it can return a list if we ask about them later. So Kubernetes also checks the health of the individual services. So if Kubernetes detects a crash in your service, it'll automatically try to restart it. And in addition to these kind of basic checks, Kubernetes also allows you to add more subtle health checks. So, for example, perhaps your database hasn't crashed, but maybe it's just really slow. So Kubernetes can track this and direct traffic to a backup if it detects that slowness. And so, it also can incorporate the load balancing piece. So, modern services, they scale horizontally by, essentially duplicating the service. And the load balancer is the key piece that distributes and then coordinates traffic across those duplicates. So Kubernetes makes it really easy to incorporate a custom load balancing solution, maybe like an HA proxy or, a cloud provided load balancer, maybe something from, AWS or Azure or Google Cloud Platform or something like Red Hat OpenStack. The third thing that it provides is resource management. And so every computer, has a limited amount of central, of computing power, right? The CPU, the power and memory, it's all limited, it's all finite. And so an application that, transcodes video, it might be CPU bound, and then an application that parses text might be memory bound. All that's to say that, the video application is going to run out of CPU power first, whereas the text parsing application is going to run out of memory first. And so completely running out of either resource is going to lead to, the system being unstable and ultimately crashing. And so proper resource management is really the result of intelligent scheduling. Kubernetes ultimately will schedule applications to appropriately use resources like CPU power, memory, while continuing to stay cautious about overutilization that can lead to system instability. So what are the benefits of Kubernetes? So, we've talked a little bit about these already, but scalability is a big one. Kubernetes automatically scales your cluster based on your needs. So it saves you resources and ultimately saves you money. Imagine you run, online event ticketing service where, you can purchase tickets 24 hours a day, 7 days a week, and there's a load that's variable in time. And so you have a rough idea of what that load or what traffic looks like when tickets go on sale during the day, and you know that evenings are typically not as strenuous on your system. And so there are a few popular events that might be causing, spikes in that traffic. So in this scenario, you'd want your cluster to really dynamically scale to meet your demand. And with Kubernetes, there's a cluster autoscaler and then a horizontal pod autoscaler. Those adjustments happen automatically because of that. So based on traffic, whether it's a spike or a dip, Kubernetes is able to scale up and down, and left and right, so to speak, outwardly. So, the second benefit is really portability. You can run Kubernetes anywhere. It runs on site in your own data center. You can run it on a public cloud. It runs in a hybrid configuration of both public and private instances. But really, the nice thing is that it's standardized across your entire infrastructure. So, once you learn how to use Kubernetes in one environment, those commands are used in all environments. There's also a consistent deployment, right? So Kubernetes deployments are consistent across any infrastructure. Containers embody the concept of that immutable infrastructure, and all the dependencies and setup instructions required to run your app, or they're bundled with the container. And this is sometimes called the pets versus cattle argument. Pets have unique personalities. We tend to give them names, so you might recognize that a server behaves strangely and start remembering its name. So you spend some time patching it. You create a customized environment to run your production applications. So you might be scared to just kill off the server and replace it with another one, right? The fear often occurs because it's difficult to remember, how this server was set up or what changed after the initial setup. Containers, on the other hand, are designed like cattle, right? They're mass-produced and they're identical. They set themselves up the same way every time because they're immutable, and additional configuration changes are prohibited. So there's no fear in killing a container and starting another. The consistent experience means developers can spend less time debugging and more time delivering business value. And ultimately, that leads to separated and automated operations and development. So it's common for operations and development teams to be in contention. We talked about that a little bit earlier. Operations teams really value stability, and they're more conservative about change. And development teams, they value innovation. They want a high change velocity. Kubernetes resolves the conflict, right? So thanks to the intelligence and automation of Kubernetes, the ops teams can feel confident in the stability of the system. Meanwhile, containers save developers time. They empower rapid iteration cycles. So let's take a look at kind of the basic Kubernetes architecture. Kubernetes is software for managing containerized applications on a cluster of servers. And so these servers are either, master or worker nodes, and together they run applications or services. So, first you have the control plane, and, the control plane is roughly equivalent to the concept of a master node. It acts as the brain of the cluster. And so scheduling, the service discovery, load balancing, resource management, all of those capabilities are provided by the control plane. So for this kind of high level architecture discussion, we're not going to get into the details of those functions. We already talked about those a little bit, but let's look at kind of the parts of the control plane. So you have your API server, the Kubernetes API server. It's the point of content for any application or service, and any internal or external request, it goes to the API server. And the server determines if the request is valid, and then it forwards the request that the requester has the right level of access. So, definitely role-based access control, a big part of this. Then you have etcd. The control plane is the brain. Etcd is where your memories are stored. And so, a Kubernetes server without etcd is like a brain that can't remember anything. It's a fault-tolerant, inherently distributed kind of key value store. It's a critical component of etcd, and it acts as the ultimate source of truth, for your entire cluster, whether it's storing cluster state or configuration. On the worker node side, a worker node in Kubernetes runs an application or service. There are a bunch of worker nodes in a cluster, and adding new nodes is how you scale Kubernetes. You have kubelet, and that's kind of a tiny application that lives on every worker node. The kubelet, it communicates with the control plane, and then it performs requested actions on the worker node. So if the control plane is the brain, kubelet's like an arm. The control plane sends a command out, and the kubelet executes that command. You have the container runtime engine. So, the container runtime, it complies with standards. We talked about the OCI specification, Open Container Initiative specification. It sorts of running the containerized application. So it's the conduit between, your portable container and then the underlying Linux kernel. And so what's missing from Kubernetes? So, it offers the portability, the scalability, the automated policy-driven management to its users, but it's not a complete solution. It doesn't include all the components needed to really build and run and scale containers in production, like the OS. It doesn't provide the CI/CD tooling, the application services, storage. A lot of work goes into setting up roles, access control, multi-tenancy, security default settings. Kubernetes does provide pluggable interfaces for a lot of those. A lot of customers, when they first start working with Kubernetes, they're having to create those services themselves. But ultimately, there's a lot of different stuff that you have to do on your own. Metrics, self-healing, routing, all of your storage and networking pieces. How do I get my services to be able to talk to each other? How can we aggregate all the logs across all of these different services, across all of these different environments? That's what makes it really, really tough. And if you look at this is one of my favorite infographics that we have. This is essentially, this is compiled by the Cloud Native Computing Foundation. They're essentially a governing body. But what it covers is everything from the infrastructure through application developer services, observability tools. This is essentially the whole stack, and it gets more and more difficult every single time. So, somebody who's kind of doing a build your own Kubernetes cluster that doesn't have kind of that container platform, they're having to pick and choose pieces from the database side, from the registry service side, from the CI/CD side, and build their own without the use of a platform. And ultimately, you can install Kubernetes and start playing around with it really, really quickly. You could probably be up and running with a Kubernetes cluster in 15, 20 minutes. But establishing it as the platform for enterprises to run, business critical applications, it takes a lot more. And so, really getting it ready, there are a lot of things that need to be pieced together and tested and hardened for, actual operations. So let's look at one key component, the identity management, right? So, with Kubernetes, you're providing access to critical internal systems to your employees, to your partners, and then ultimately to your customers. And so you have to adhere to, security rules that are established inside of your organization. And the way to do that, you have to write an integration between Kubernetes and maybe your company's approved LDAP. And that requires knowledge of DEX, which is an open source identity system. You have to have knowledge of Kubernetes and the integration systems to LDAP. And so similarly, you have to hook up Prometheus, which is an open source monitoring and alerting, or hook up another monitoring system so you can get full visibility into your Kubernetes operations and testing and in production. And so that's one component right away that you have to have knowledge on all these other services. So that's where something like OpenShift comes into play. And so, no matter what architecture you choose for your applications or what programming language the developers are writing their applications in, what services you want to use as the building blocks, OpenShift provides really a single and consistent development model across the build, test, deploy, monitor, and review lifecycle of the application. So some of the things that it provides, so self-service infrastructure, right? It allows developers to provision what they need on demand, and they don't have to wait, for infrastructure resources. They don't have to wait days or weeks or months sometimes. It also provides consistent environments. So, OpenShift makes sure the environment provision for developers and across the life cycle of the application is consistent from the operating system. Whether that's libraries or runtime versions, even the application runtime in use, all of that in order to remove the risks that originate from inconsistent environments. It also provides automated build and deployment. So, OpenShift gives a choice to developers to build their containerized applications themselves, or they can have the platform build containers from the application source code or the binaries they've already got. The platform automates deployment of those applications across the infrastructure based on the characteristic that the team has defined for apps, such as how much resources should get allocated or where on the infrastructure they should get deployed to be compliant with these third-party licenses. I mentioned before, but continuous delivery pipelines. OpenShift provides out-of-the-box support for CI/CD pipelines so that development teams can automate every step of the application delivery process and make sure it's executed on every change that's made, to the code or the configuration of an application. And then configuration management, another really big piece. Configuration, sensitive data management, it's built into the platform to ensure a consistent and ultimately environment agnostic app configuration. It's provided to the application no matter what technologies are being used to build the app or what environment it's being deployed to. And then ultimately, application logs and metrics are huge key, right? Rapid feedback is important aspect of application development. And